So for this question, we're told the discrete random variable x has the following probability distribution, where a, b, and c are distinct integers, where a is less than b, which is less than c. All the probabilities are greater than 0. A, find the value of a, the value of b, the value of c. Show your working clearly. For part A, we know that all our probabilities in our probability distribution table should add up to 1. So we are going to write log A base 36 plus log B base 36 plus log C base 36 should equal to 1. Using our laws of log, we can rewrite this as log A, B, C base 36 is equal to 1, which therefore means that A, B, and C is 36. This means that we now have to use our factorization to look for what A, B, and C might be. So using our factors of 36, we have 1 times 36, where we can further factor 36 as 6 and 6. However, we know this can't be the value of A because we're told in the question that the probabilities are greater than 0. If we had log of 1, then that means one of the probabilities would have to be 0. So we know that that cannot work. Another factor of 36 is 2 times 18, and we can further factor our 18 into 3 and 6. Now that could be a possibility, but let's just look at the other factors of 36 that we may have. We have got 3 and 12. And again, if we further factor our 12, we can put this as 2 and 6. So this is literally the same as what we've just got earlier. Another factor could be 4 times 9. If we further factor our 9, we would have 4 times 3 times 3. Or we could factor our 4 and we could have 2 times 2 times 9. However, both of those would not work, because in the question we're told that A, B, and C are in ascending order. None of them are equal to each other, so that would therefore not work. And we're therefore going to have to go with these factors that we got here, which means that our A being the smallest will be 2, our B being bigger than A will be 3, and C being bigger than A and B would be 6. So those are our answers to part 1, part 2, and part 3 of A. We're then told the independent random variable x1 and x2 each have the same distribution as x. Find the probability that x1 is equal to x2. So we are looking for the probability that x1 is equal to x2. And we have found our values for A, B, and C. A is 2, B is 3, and C is 6. This means that we are looking for the probability that both are going to be the same variables. So we are looking for the probability of getting a 2 and a 2, or a probability of getting 3 and 3, or the probability of getting a 6 and a 6. Our log of 2 base 36, we're going to square that because we're looking for 2 and 2. We're going to add it to log 3 base 36 and square that as well, plus log 6 base 36 and square that as well. If we put these into our calculators, we're going to get 0.034. For the second one, we get 0.094. And for the last one, we get 0.25. And if we add all those, we get a final answer of 0.381.